Welcome to Sundar's lecture. This is lecture number 99, and in this lecture we are going to see three-phase power measurement, right? So what are all the topics we have seen in the previous class? See, in 98th lecture we have taken some problems, right, related to that three-phase circuits, balanced three-phase loads, and we have solved them to get what is the power, what is the real power, power factor, reactive power, all those kind of things with the delta connection and with the star connection, and what is the relation between star and delta connection. We have seen those kind of problems in the previous class, right? Now in this class it is a new topic, like we are going to measure the power. Now what is the power in a three-phase circuit? For example, let us take a star connected load like this, star connected load, and we need to measure what is the power in each phases. So for example, see here, in wattmeter, see, always you have to understand certain things. Wattmeter only reads the real power, reads real power, right? What is real power? What is real power? If even if it is a single phase or it may be three phase, both are same. Yeah, if it is a real power, then it will be V phase and then it will be I phase cos pi, cos pi. And what is this pi? This pi we generally call it as angle between angle between voltage and current, voltage and current, or power factor angle. This is power factor, right? What is this one? This one we generally call it as power factor, or this angle that particularly this pi will come. Maybe we can write it as pi is equal to tan inverse of x divided by r. We can write like that, right? So there are many formulas. We have seen these formulas in the previous lectures. So now only this wattmeter reads the real power. That is the point you have to note here. For example, what is the current flowing in this phase? This is I phase, right? I phase. Maybe if it is balanced three-phase load, then the magnitude of current will be same, right? Magnitude of current will be same. All those kind of things we have seen. And if you want to write what is the power measured by this wattmeter, now that wattmeter will measure this power. Maybe I will take it as P1, that is the, or maybe I will take it as PR since it is connected in the R phase with the neutral. This one. What is this voltage here? What is the voltage here? It is VRN, right? It is VRN. VR and then N. And then what is the current here? It is IR and cos pi, simply. And what is VRN and IR? It is I phase values, right? So PR will be is equal to, I can generally write it as I phase, V phase into I phase into cos pi. So this is the power measured by this wattmeter. Put this wattmeter here, put this wattmeter here, so that you will get all the powers PB and then PB and then PY. You will get these values, right? And what is the total power? Total power can be written as PR plus PB plus PY. See, try to understand PB and PY, everything it may be. You see, try to understand all B phases and I phases are same here, right? Why? Because this is a balanced circuit. This is a balance. So you will get PT is equal to 3 times this value. 3 times B phase, I phase, cos pi, cos pi. So this is the total power that was drawn by this three-phase load. This is the whole idea, right? You try to understand. Now, for example, you have one wattmeter here. So I will see here. See here. Look at this one now. What is this one? Simply we can write, right? What is P here? What is the total power? That W1 plus W2 plus W3. That is the total power, right? You can easily understand, or maybe P is equal to 3 wattmeter readings. Maybe I don't need to write that, right? This is the wattmeter reading. Be whatever you are read in wattmeter 1, 2, 3, that will be the answer, right? And you see here, if we draw, if we do like this, for example, this one, three-phase power measurement with 1 wattmeter method, and you can multiply that with 3 simply. 1 wattmeter method. This one is 1 wattmeter method. 1 wattmeter method. Why I am saying this one? Since this is a balanced circuit, if you measure one value, you can multiply it with 3. Simply you will get the answers, right? That is also possible. But if you are getting like this is actually 3 wattmeter method. 3 wattmeter method. 3 wattmeter method, right? You have to put 3 wattmeters separately in each basis and you need to find what is the value. And this one, this is very important, 2 wattmeter method. With only 2 wattmeters, we are going to measure the whole power. Oh, what is the total power in the circuit? That is in the star connected circuit, 2 wattmeter method. This one is really important. This you will use this 2 wattmeter method in so many places to measure the power of DC three-phase induction machines and all. Wherever you go in AC machines, you will see this 2 wattmeter method, because you always use this 2 wattmeter method to measure. In laboratories also, you will use 2 wattmeter method to measure the power, right? So it is very important. See what we will do now. See here, what is the current in this wattmeter? What is the current in this wattmeter now? This current is IR, right? This current is IR. Maybe I will write it down. The current, instantaneous current. Maybe I can write it as instantaneous current, right? Current. It is IR. Maybe I will take it in capital letter. I have written small letter here. Maybe I will take it in capital letter here. Okay, maybe small letter. I will take in small letter. That is very easy. So it is IR. And what is the voltage? What is the voltage in this wattmeter now? This is V. It will be ER, and then ER between ER and B, right? So I can write it as voltage where these two are connected, R phase and B phase. It will be ERB. ERB. And what is ERB? We know, right? If we are writing ERB, we have already seen these kind of things. That is ER minus EB, right? This is the first wattmeter. Wattmeter number one. Wattmeter number one. That I will take it as the voltage. Maybe I can write now. Maybe you see here. PW1, wattmeter reading 1 will be is equal to ER minus EB, that is the voltage, and what is the current here? It is IR. That's all. Make this as equation number 1, right? Now you go for the second wattmeter, wattmeter number 2 now. Wattmeter number 2, right? And what is the current here? See here, it is IY, right? So the instantaneous current, instantaneous current, here it is IY, it is IY. See what is the current flowing here in this wattmeter, IY. And what is the voltage? What is the voltage? That is also important. What is the voltage? See here, it is connected between Y and B, right? So EYB. And if I am writing what is EYB, that is equal to EY minus EB. I told you, see, I am not going to explain you why I am doing this one, since I have said you many times. We always use, if it is EYB, it will be EY minus EB, right? Anyhow. So I need to write what is the power in the wattmeter number 2. That is PW2 is equal to EY minus EB into IY, right? So this is equation number 2. And you see now, what is the total power? Maybe if I am putting PT, if I am putting, maybe I will use a different color. Okay, fine. Now if I am using a different color here, PT, right? PT is equal to what? PW1 plus PW2. So add these two values now. What you will get, if I am adding this one, this is the first equation, right? So ER minus EB into Iy, right? That is the first expression, and then plus. And if you are going for this one, what you will get, it is Ey minus Eb into Iy. So you just put all the values inside and get what is the resultant one. So if I do so, it will be Iy Er, that is Iy Er minus Iy Eb plus, maybe I will take this one. This one will be Iy Ey, and then if I multiply this, I made a mistake here. This is IR, right? Okay. Okay, now you see this one. Sorry, I made a mistake. I put Iy, right? Now this one will be IR ER minus IR EB, and then if I multiply this one now, plus will be here, it is Iy Ey, and then minus Iy Eb. See, you just take these two, take Eb commonly outside. So what is the other terms? It is IR ER, that is the first term, plus Iy Ey, that is the second term. You take this one Eb commonly outside, you will get what? IR plus these two terms Iy, right? Common. Now one thing you know, right? What is that one? If it is a balanced three-phase network, because all the impedances are same, then IR plus Iy plus Ib will be is equal to what? 0. The neutral current will be 0 if it is a balanced three-phase circuit, right? So we will take this to the next page. So you see here. Now what I can write here, instead of this IR plus IB, IR plus Iy, I can write minus IB. I can write minus IB, right? So if I write that one, it is IR and ER plus Iy into Ey. See here, if I put minus Ib, then it will be plus, right? So it will be plus Ib into Eb. This is the total power. Try to understand. Try to understand. The power will be is equal to IR ER plus Iy Ey plus Ib Eb. See this one. See this one now. This is the total power measured. See, try to understand this power, which is nothing but this is R phase power, this is Y phase power, this is B phase power. All are added now. So the total power will be what? All three phase power. Three phase power. See, we have used only 2 wattmeters. We have used only 2 wattmeters, and we have found the total power. The total instantaneous power. Actually, this is instantaneous power because we have taken the current to be instantaneous, right? Only instantaneous current. So this is the whole idea. Now what I will do, I will give you the exact calculation, exact value of the power that was measured here, and we try to find what is the real power with the 2 wattmeters, reactive power with the 2 wattmeters. Everything can be measured, everything can be used, can be determined using a formula with wattmeter number 1 reading and wattmeter number 2 reading. That is our ultimate aim, right? We will do that. See this one now. This is 2 wattmeter method, phasor analysis, right? We need to find what is the reading that was measured in W1 and W2, and we try to manipulate that values to get what is the real power, reactive power, what happens if wattmeter number 1 is 0, what happens if wattmeter 2 is 0, and it will give you so many information. 2 wattmeter method will give you so many information. Anyhow, we will take RYB phase, RYB sequence, right? Sequence. These things we have already seen. What is that one? Actually, if I am drawing, if I am taking this to be VR, and the 20 this 120-degree, that will be maybe I don't have space here. I will draw here. See here. Let us draw the diagram. Let us draw the phasor diagram. Right? If this is VR, and if this is Vy, and if this is Vb, right? We know these kind of things, right? If this is VR, this is Vy, this is sorry, this is Vy, this is Vy, and this is VB, right? Phase voltages, VR, VY and VB. And now if I am going to draw the currents, that is the currents, right? This one, maybe I will take RLO, right? RLO. If it is RLO, then the current VIR will lags by some angle. This is IR, this is IR, and what is this one? This is pi. You know these kind of things, right? You know these kind of things, and right, and then IY, where it will come, maybe around here. And what is this one is IY, and what is this one? This is pi. And also, if you take the IB, maybe this will be IB, this will be IB, and what is this angle? This is pi. Right now, this is the diagram. You know these kind of things because it's the RL load I am taking like this. Now you see, you come here now. You come here. Now you see the wattmeter. What is the current here? It is IR. That the wattmeter one. Wattmeter one. The same thing. Wattmeter one. What is the current? It is IR. It is IR. And what is the voltage here? What is the voltage here? It will be VR minus VB, right? Both the voltages, VRY voltages. It is VR and B, right? So voltage here, it is VRB, right? Now what you need to do, you need to find what is the angle, because whatever the wattmeter reads here, that is PW1 due to wattmeter number 1, it reads the voltage VRB voltage, and then this current is IR, and cos of some angle, right? And what is that angle? You have to understand. You have to get the values of that particular angle. What is the angle? Which is nothing but these two. Between these two, whatever the angle you are getting, cosine angle, whatever you are getting, that will be read here. Try to understand, because this wattmeter reads only the real power. That is why I am repeatedly telling you this wattmeter reads the real power. And what is the voltage here? It is a VRB. And what is the current here? It is IR. And what is the angle between these two? That angle will come here in the cosine, right? I need to find that angle. And I need to find what is VR now. Because I know what is IR here. I need to find what is VRB. Now what is VRB? VR is already here, right? It is VR is already here. And if you extend this one, so anyhow, I have to write this too. VRB will be is equal to what? VR minus VB, right? So you just extend this one. Now it becomes a minus VB, right? This one. If you extend, what is this one? Simply it is minus VB. And if you add these two, maybe if I put like this, like this, and what is this one? Simply what is this one? This is nothing but VRB, and you need to find what is the angle between VRB and IR. See here, angle between this particular phase and this particular phase. What is this one? Total. What is this one? What is the total angle here between these two? That will be 30 degree, right? That will be 30 degree. Simply if you take the angle between the whole thing, maybe I will write here, this between these two is what? 30 degree, right? And what is the angle between these two? If I write here, what is that one? 30 degree minus pi. 30 degree minus pi. That is the angle between this VRB and IR. If this is total 30 degree minus of this value, that is 30 degree minus pi will come here, right? And now what I can do here, that is wattmeter number 1. Maybe I will take it as W1, not PW1. Maybe I will take it as PW1 will be is equal to, it is VRB, and it will be IR cosine of, what is the angle here? That is 30 degree minus pi. See, try to understand. We are getting it very close to the results now. These kind of things, if you understand it clearly, this is the diagram for RYB sequence. All these kind of things will help you. That is why We have done these kind of things many a times in our previous lecture. So W1 reads VRY, IR and cos of 30 degree minus pi. Maybe I will write this one in another angle. What is VRY? What is VRY? It is VL, right? It is VL. Line voltages. And what is IR? That is also line current. And this value will be cos of 30 degree minus pi. See, in star connected load, IR and IL will be IR phase voltage, phase current and line current will be same. You don't need to be very confused, right? So this is the equation now. VLIL cos pi. 30 degree minus pi. 30 degree minus pi. Anyway, see now what we will do, we will go for the wattmeter number 2. Right. Now you see here, we will go to the wattmeter number 2. We will study what is wattmeter number 2. Same diagram, whatever we have taken in the previous one. This ROAB sequence, this is RL load, so this is VR, VY, VB, and the angle between these two will be pi, right? This is IR, this is IY, this is IB, right? The angle between the lagging angle, pi, right? Now what we will do, the current, what is the current here? The wattmeter takes the current of IY, right? This is IY, current of IY, and what is the voltage here? See, this voltage is VYB, VYB, right? Phase Y, phase B voltages, right? So what will be this wattmeter 2 now reads? What will be this wattmeter 2 reads now? It is VYB and then IY cos of some angle, and what is that one? So I will write this one, that is VYB can be written as what? It is Vy minus Vb, right? Vy minus Vb. See here, Vy is already here, and if I draw this value, this is nothing but it is minus Vb, right? So I have drawn these two. Vy is here, Vb is here. So what is the resultant value? What is the resultant value? This value will be Vyb. So if I add these two, just add. Now you see, I have to find what is the angle between this VYB and IY. IY is here, VYB is here. See here, what is this angle? What is this angle? This is 30 degree, right? This is 30 degree. I need to find what is the angle between these two faces. 30 degree plus pi. 30 degree plus pi, right? So what will be here? It will be 30 degree plus pi, simply you can write. So what will be the wattmeter 2 reads now? It is VYB and then IY cos of 30 degree plus pi. Or in other hands, I can write this is line voltage, line current cos of 30 degree plus pi. See, try to understand. We have found what is the value of W1 and then W2. This is W2 and this is the value of W1. And what is the total power now? We will take it to the new page because that is very important. We have to measure power. So W1 will be is equal to, what is the W1 we got? VLIL cos pi. See, VLIL cos of 30 degree minus pi, right? And what is W2 we got? It is VL, this is IL. This is VL, IL cos of 30 degree plus pi. See, try to understand. This is what we have got, right? So now, what is the total power? That is real power. P will be is equal to W1 plus W2. You just add these two, what you will get? It is VL, IL. If you add these two, you will get VLIL. Maybe if you are taking it commonly outside, add these two and take VLIL commonly outside, what you will get? It is cos of 30 degree minus pi and then plus cos of 30 degree plus pi, right? So if you further expand this one, so P will be is equal to, it is VL into IL, and what is this one? Cos A cos B minus sin A sin B, right? That will be this one. So cos A cos B, right? That is this one, minus sin A sin B, that is this one. That is the first one, and then plus this value, that is cos A, cos A, cos B, cos B, minus then plus sin A, this is plus, right, because this is plus, sin A, sin B, sin B. And if you further simplify this, I will straight away write, because these kind of things are all you can easily do, right? So I will straight away write. Maybe it is easy to see here, this value and this value will be cancelled out. And what is the other thing? So it is VL into IL. What you will get? It is 2 cos 30 degree into cos pi, into cos pi. And what is 2 cos 30 degree? What is 2 cos 30 degree? It is very simple. See here, 2 cos 30 degree, it is root 3, right? So what we will get here? P will be is equal to 2 cos 30 degree, it is root 3. So root 3 VL IL, and what is this one? Cos pi. See, try to understand. Try to understand this one very clearly. See, we got the answers now. We got the answers. We got the answers. What is this one? This is nothing but 3-phase power, right? 3-phase power. Formula for 3-phase, real power. Real power. So the thing is, if you add W1 plus W2, what you will get? You will get real power. You will get real power of P. Total power P. Right? Can you understand? That is this one. Maybe I can write this as now 3V phase I phase cos pi. Cos pi. Because in a star connected circuit, I can replace this with maybe VL is equal to root 3 times V phase, and that root 3 V 3 and phase voltages and line phase current will into cos pi. This is also a correct value, right? So W1 plus W2 will be is equal to 3 V phase I phase cos pi, right? This one. And I am going to find what is the value of the sin pi also. What it will be now. Right, now what we will do, we try to minus these two now. W1 minus W2. Let us see what happens. Right, here we have just added these two. Now we will minus it. So it will be VL into IL, and then what you will get here, if you minus this one, I will directly write this one, that is cos 30 degree, and then cos A cos B minus sin A sin B. That is the first term, right? And then it is a minus here. So what you will get here, this will be minus of, you will get cos A 30 degree cos B, and then here it is minus sin A sin B, right? You will get like this. So if you further do this one, W1 minus W2 will be is equal to VL IL, and if you multiply these two, this cos terms will be cancelled out, right? Cos terms will be cancelled out, and you will have 2 sin 30 degree into sin phi. You just do this one by yourself. You will get this one, right? Now you will get an expression like this. And you see 2 sin 30 degree is what? 1. And this value will be 1. So finally, I will get W1 minus W2 will be is equal. This value becomes 1. So it is VL IL sin pi. Sin pi. Right? Try to understand. Right? VL IL sin pi. Right? This is the value. And if you want to find what is the Q, what is Q? Root 3 VL sin pi, right? So I can write like that. See here, one thing, what is Q we know, it is root 3 VL IL sin pi, right? We know this one. And you see here, simply we are getting W1 minus W2 to be VL IL sin pi, right? So what I can write here, Q can be written as root 3 W1 minus W2. Can you understand? This is nothing but the reactive power formula. Reactive power formula. Try to understand my point. And P will be is equal to what? Straight away it is W1 plus W2. That is what we have derived here, right? We got it straight away. We got it straight away. That is W1 plus W2. We are getting this value. So this is the real power formula. This is the real power formula, and this is the reactive power formula, right? Try to understand this one clearly. And if I just divide W1 plus W2, W1 plus W2 divided by maybe I will do it in another way. See, I take this one. See here, if I minus W1 minus W2 divided by W1 plus W2, what I will get? See this one, what is W1 minus W2? It is, maybe I will write this one as VL, okay, anyhow, I will write it as this value. This is VL, IL sin pi, right? Sin pi. That is W1 minus W2. And what is W1 plus W2? It is 3 VLIL, right? Root 3 VLIL cos pi. Root 3 VLIL cos pi. That is root 3 VLIL cos pi. Why I am doing this one sin pi by cos pi? Maybe that is very easy, right? So I can bring this one to the other side. So that is sin by cos, it is tan pi, right? So tan pi, which is equal to root 3 times W1 minus W2 divided by W1 plus W2. So in other hand, what I can write here, pi, that is the perfect triangle can be written as tan inverse of that is root 3 multiplication of W1 minus W2 divided by W1 plus W2. See here. See here, how many things we are getting here. With only this W1 and W2, we will get the value of pi, the value of reactive power, the value of real power. We got everything. We got everything, right? So I will give you some 6 or 7 points. What happens if the angle are 60 degree, 90 degree, 30 degree, and what is the nature of the load? That we will see in the next class with some numerical examples, right? Thank you. Go through this one anyhow. What are all the topics we have seen today in this class? See, we have started with the measurement of power, right? We have started with the measurement of power, 3-phase power measurement, and we have said that the wattmeter will reach the real power, that is V phase, I phase, cos pi, right? And we have seen that in single, if you read this one and you multiply this with 3, you will get the values. And 3 wattmeter method, straight away you put W1 plus W2 plus W3. And this 2 wattmeter method is very important. Why? Because with only 2 wattmeters connected like this, we can get what is the total power, right? Total 3-phase power. And we have proved that one with the instantaneous power. And we have taken this one, that is the 2 wattmeter method phasor analysis, and we know, and we try to find what is the value of W1 and W2, right? So W1 this value and W2 this value. If you add these two, straight away you will get the real power. If you minus these two, you will get the reactive power. Anyhow, you are not getting direct value. You have to multiply that with root 3. And we find what is the value of pi with the W1 and W2, right? Go through this. We will see in the next class. Thank you.